Thanks for choosing to listen to this Late Night Linux Family podcast. We're only able to do this because of the people who support us. None of our shows are paywalled, but our Patreon supporters can get most episodes early and never hear any ads. Learn more at latenightlinux.com/support or support us by telling a friend or colleague about everything we do. Hello and welcome to episode 157 of Linux Dev Time. I'm Joe.
I'm Kevin.
And I'm Andy.
Good to talk to you again. Amleth's away in Canada, I think, of all places, so we'll have to crack on without him, but he'll be back next time. Andy, you posed the question, macros, are they a superpower, a necessary evil, or a mistake? And I said, I don't understand the question. So you're going to have to explain to me, first of all, what is a macro?
Okay, so a macro is a general term for something you can do within a programming language that lets you step outside of that programming language. So you might need to do something repetitive where you're going to end up writing the same bit of code but slightly different 10 times. And then some languages provide you this thing called a macro that means you, instead of that, you can say, do this 10 times, and it will effectively generate code for you. One way of thinking about it is that it generates code.
Yeah, it's kind of like a programming language within a programming language. And exactly like Andy said, it's usually useful if you have some like syntactical or like type level thing where you want to run a program on the source code of your program and do some sort of changes to it. But what's interesting here is there's a bunch of different ways in which you can go about this. And all the various languages provide either different types of support or none at all. And so that's where it gets interesting is macros themselves are both like very powerful. They can also be extremely evil, and they can also be everything in between, I guess. So like the way that Andy posed the question is the answer to it would be like, yes, they are all of those things or can be all of those things.
So what I'm getting from this is that it's like a more complicated version of find and replace. Like say, for example, I've got a load of bash scripts that relate to backups and they've all got a host name or an IP address in there and I want to find and replace it all. I can do that in a text editor really easily. But is it that kind of principle, but just much more complicated?
I mean, it is that kind of principle, but it's more like if you wrote a bash script to produce all of those bash scripts.
Right.
You never look at the produced bash scripts. You only look at the original bash script. And if you need to make an update to all of them, you just make it once in that original bash script and they all get automatically updated.
The interesting part here is that you may need to do that find and replace across a bunch of different places, and it kind of just generates the same thing over and over and over with whatever input you gave it. So it is very much like a find and replace, but different languages will have different constraints around that find and replace. So there could be different constraints like, is it written in the same language that you are also editing, or is it a new language entirely? And for example, Rust has, I would say, a little bit of a controversial take, but then it also has some things that are nicer about it than other macro systems. So in Rust, you don't necessarily write the macro in Rust itself. I mean, you do at the like most literal level, as in it's in the same source code and things of that nature, but you're using this sort of like domain-specific language or DSL to edit macros, and they're not actually operating on the literal text itself. You're actually operating on sort of a compiler component or like a token stream or a set of tokens or expressions. So you're not operating on the actual characters, which would seem more intuitive. I just want to like search for a word and then maybe replace that word with something else. You're actually operating on more of a like syntax level that the compiler is aware of. So while this makes it a little bit more difficult to write the macros, and sometimes that's why Rust can be a little bit frustrating in the macro department, it also makes it more powerful and then even more safe when you're not just doing like a literal text manipulation or text find and replace.
Right. I think that we need a concrete example here. One of you is going to have to tell me something that you can achieve or something you have achieved by using macros.
Let's go to the C path first, because I think like talking about the simplest version of this might help us make our way into it. So in C and C++, you can write macros, but they really are just like text replacement engines. So the most common use for them is to just include one file inside another. C doesn't have a module system. Actually, I feel like modern versions of C might have a module system, but let's pretend that that doesn't exist. So you'll see hash include. People talk about hash including things, maybe as part of, you might have heard people say that more generally. Where that comes from is just saying include this bit of code here in this inside, as if it was inside this file. So include this file inside this file. So that's a really simple thing that you can do with C macros, with the C preprocessor. Another simple example, which probably is still not really getting there, we need to do better than this, is just include this piece of code if I'm on a certain platform, and don't include it if I'm not. And by include, I literally mean this text is either there or it's not there based on some kind of thing like what platform I'm on.
And then you can do further things like, let's say if you were to take that one example of do something in a particular architecture or not do it on another architecture, you can also do stuff like take a particular block of code, like maybe an if-else statement, and you can repeat that for all of the inputs that you give it. So you could say something like you have what looks like a function, which would be the macro itself, and it takes an input of maybe a list of items. And then your macro would be saying, like, for this list of items, write out this if-else block, for every one of them. And it's an easier way to do something repetitive or to do something at the syntax level, like kind of before the compiler sees it. And there's also some downsides to this. So because it's just a like literal text kind of before the compiler runs, that's why it's called a preprocessor. It gets processed before the compiler sees it. You can actually end up doing some weird things where you can like pass in different variables or different parts about the code, and then whatever happens inside of your macro can also affect what happens outside the macro too. And what I mean by inside and outside the macro, I mean the actual literal text that you're writing in the macro. If you pass in an actual function or pass in an actual variable, that variable exists both inside of this macro and outside of that macro syntactically. And this can get confusing when you go to actually compile this stuff, and your macro could be doing something nefarious that you never see, because in the literal source code, you just see like the macro call and whatever its inputs are. But the macro itself can actually affect things outside of the macro, even without them being passed in. So there's like lots of weird stuff that can happen in macros. And that's why they're also considered like kind of scary, because of the things that it allows you to do that it doesn't seem like it should be able to do. So they're not like a function. It's almost like if you had like global variables everywhere or something along those lines, where you can just kind of manipulate whatever you want, because it's just happening at the like syntactic source code level.
You two have a very funny idea of concrete examples. Let me give you an example of a concrete example, right? Someone could ask me, what are ZFS snapshots, right? And I could talk to you about taking snapshots, replicating them offsite and everything. And that's what you two just did. Whereas a concrete example would be, I was working on a Word document and then I accidentally deleted everything in it and saved it, and now it's empty. Well, if you had ZFS snapshots, you could go to one from 10 minutes ago, restore that snapshot, and then you would have all of your work left. That is a concrete example, chaps. That's what I'm looking for.
Let me try. So I was working on a bit of code where there were lots of classes, lots of objects that were all very similar. And one of the things about them that was similar was the way you read them in from a file. So each of these objects had different properties in them. So one of them had like 2 integers and a string, and one of them had a string and a, complex number or whatever. But every time you read them in from a file, which is something we needed to do, every time there was an integer, you had to do this long sequence of steps to read that thing in from the file. And it was the same in all the different classes. And I ended up writing that code, 500 times for every time I found an integer that was inside one of these classes. But what I could do instead was write a macro that just generates the code for reading from a file, or even just generates the code for reading an integer from a file, if I wanted to break it up that way. In my code, I would just say, read integer from file, and it would spit out underneath in code that I never saw, but I knew was there, all of that gumph about how to read an integer in from a file.
Another example that I can give is similar-ish to what Andy was saying, but for example, there was a bit of code that had to do with the way that we handled bytes coming off of wire, and how we parse these bytes and what we do with them. So instead of writing this for all of the different types of primitive types, like, a uint 64 or 32 or 16 or 8 or whatever it is, all those various like primitive types, you write it once inside of a macro, and that macro takes as input the type that it wants to operate on. And then in the actual source code, what you're writing is implement all the code macro with a uint32, implement it with a uint64, implement it with a uint8, or whatever your various types are. And it's basically just like copy and paste over and over and over, but it's copy and paste that I don't actually have to like go through. It's not 1,000 lines that I have to read through now. I can read through the single macro call with all the various types inside of it. And if I'm curious what the macro is doing, I can just expand that macro to either the macro source itself or have it like fully expanded in, an IDE, depending on what kind of editor you're using. So it's like a really fancy copy and replace, at least in this example. There are many, many other things you can do, but you can think of it like a very, very fancy copy and paste.
Right. So as you said earlier on, it's kind of a small program to work on your program in a way.
Exactly. So another example that I've got that I use a lot is I used to write lots of Java code, and Java doesn't have any macro system at all. And one thing you need to do when you're writing code is you need to know whether two things are the same or not, right? So in Java code, you have this equals thing that you have to implement. Like you implement a method that says, is this thing the same as this other thing? And inside there you have to check, is the first bit of me the same as that bit of them? Is the second bit of me the same as that bit of them? And so on. Go through all the different bits. And if you write a lot of Java code, you'll know exactly what I'm talking about. And you'll have written hundreds and hundreds of lines. Or maybe your IDE will have written them for you, because in later years, IDEs started generating this huge splurge of code for you. But it's the same every time. And by having to type it out manually, I just give myself the opportunity to introduce a bug, or my IDE introduces a bug in that code. When I'm doing the same thing in Rust code, if I want just the really boring version of are these two things equal, I can just ask a macro that Rust gives me out of the box to produce that code for me, and I never have to see it or even know it's there.
Yeah, and what we haven't really talked about yet is why would I even want a macro? I mean, we kind of talked about like boilerplatey stuff or stuff that's like very copy-paste heavy, but we haven't necessarily talked about like why would you reach for a macro? Because it kind of sounds like, okay, if you need to do some logic, make a decision and like have an output, like you're already writing a program. Just write a function. It kind of sounds like a weird function. Like, why would you ever do anything other than a function? And here, where you most often start to reach for this is when you want to operate like outside of some sort of runtime. Like you don't want this code to actually run on the user's machine or anything. You want this code to run either at or before compile time to handle stuff outside of the actual language itself. And that could be things like types, or it could be things like function names. Like maybe you want to generate a ton of functions. It's stuff at the like actual writing of syntax level. When you find yourself like, man, I really wish I could just pass this whole block of code into a function and have it spit out a new block of code. That's effectively what a macro is a function that operates on code.
And actually, some people will sometimes, especially if they're working in an environment that doesn't allow them to use macros, they will just genuinely write a program that spits out some code as a replacement.
All right, so going back to your original question then, are they a superpower, a necessary evil, or a mistake? It seems pretty clear that it's not a mistake because they can be very useful.
And I think the necessary evil part, we've probably done a decent job at ham-fistedly describing that here because of how difficult it is to describe and all of the weird oddities about them and just kind of how hard they are to talk about. So necessary evil, I would also say that because they are useful and they are also kind of gross and hard to work with at times. They can also do bad things, and that's why there are languages like Rust that have tried to correct some of that, and in some ways they're successful, in some ways they're not. So in Rust, we've talked before about like pure and impure functions, where a pure function being it can only operate on things it's given to it as arguments, and it can't operate on anything outside of that. So Rust tries to take that kind of an approach where a macro can only operate on the code you've given it, not just like any code in the program anywhere. Whereas C is more of like the operate on any code anywhere in the program sort of thing. So there's things like that. And then there are other languages like Zig that has no macros, but it has a thing called comp time. And here, the Zig developers had the idea that what if we just let you run like an actual Zig program on your source code, and it's a very constrained environment. You can't do certain things like, I think, like allocate memory or call out to file systems or whatever. So there's certain things you can't do, but a very constrained version of still just plain old Zig operating on kind of stringish type things that end up being source code. And it turns out that's kind of a powerful way to do things. And that's what a lot of people like about Zig. There are downsides to it as well. But the nice thing is, like, you're never learning another domain specific language. You're never learning anything else. You're just using plain old Zig and plain old Zig functions to operate on kind of stringish stuff that just turns out to be more Zig. So there's cool ideas, but that's a relatively newish idea, I think. There's probably other languages that have done that before as well. But Zig is one that where it's really kind of taken off. And it's this thing called comp time.
What occurs to me is that it could be potentially quite dangerous to run these macros if you don't fully understand what it's going to do. You know, I go back to the find and replace example. One of the classic funny things is we don't want to have any of these curse words, so find and replace them with asterisks. And then you end up with places like Scunthorpe getting asterisks in the middle of it. Presumably that can happen if you wield this power when you don't fully understand what it should be doing. Like, it can presumably go and cause very serious problems.
It definitely. So, first of all, I don't think we should give up on the idea that this whole thing is a mistake, right? There are huge language families that just don't have them, right? So Java, C#, JavaScript, Python, Go, Zig, like just loads and loads of people just don't have macros because they were a terrible mistake. But yeah, so to give an example of the kinds of problems that you can see, like what you were describing, Joe, in C and C++, there are macros which will kind of repeat the thing you gave them. So if you give them a thing like, they're expecting you to pass in like 10 or X or something like that. But if you pass in something that does something, so like x.launch rockets, as the argument to the macro will then make 200 copies of x.launch rockets, all of which will get run, and 200 rockets will get launched instead of the one that you were expecting. So that's the kind of pain you get with that style of macro, because it's so close to find and replace that there's no protection against that kind of thing.
Well, and then there's another type of issue too. So like, as much as Andy and I love Rust and talk about it, for example, imagine if your find and replace, you were finding some word and replacing it with asterisks, and in the middle of that, it copied your SSH keys and sent them out to some server. Macros are effectively running other programs. Now, in Rust, technically, there are two different styles of macros, one which can do that type of thing and one which cannot. But the ones which can do that type of thing, it's effectively like arbitrary Rust code that you're running on top of syntax as an input, sure, but it's an arbitrary Rust program. You can still read and write files, you can make network calls, you can do all kinds of crazy stuff. And that is a danger. So running macros that you don't trust can be very dangerous. And there's been various attempts to make that safer in Rust specifically, like running the macros in a WASM runtime that does not have things like network access or file system access, or even running them in container, not like containers, Docker, Podman, but containerized systems to keep them safer. But imagine if your find and replace just like went off and, stole your bank account. Like, that would be terrible. And that is a thing that can happen with macros because it's just an arbitrary program running at compile time.
Well, this superpower analogy then makes sense, because Superman can go and help people from high buildings, catch them when they're falling or whatever, but he can also flick peanuts in the bar and break the bottles and then fly into an oil tanker and create a massive ecological disaster. Like, you can do some amazing things by the sound of things, but you can also do some really bad stuff accidentally.
Yeah, and that's exactly why things like some of the procedural Rust macros, or proc macros as they're called, are able to do some of these things. And people might ask, like, why didn't they just make it to where you can't do network calls, or you can't do file system writes, or anything like you can't allocate memory? It's because sometimes you need to do that thing. Sometimes it's useful. And there's that work to constrain it. But yes, that it is that type of a superpower, because sometimes you can do really good things with it.
Yeah, and if you're writing normal Rust code, you use loads of macros every day. And I think something that's come out of this conversation for me is that the biggest danger with macros is in writing them. If someone has written a brilliant macro that does exactly what you would expect it to do and isn't dangerous and you can trust it, then it's almost completely just a positive, right? It just makes your life so easy. In Rust, one of the amazing things about writing Rust after coming from some other environments is if I want to turn my thing into JSON, I just write one line of code and then it gets turned to and from JSON and I don't have to worry about it. And then the exact same code could also mean that I could get turned to and from some other format like TOML or whatever just as easily. And that's because there are macros that come with it that are just genius. Well, not come with, well, these ones don't actually come with it. But anyway, everyone uses SERDI, which gives you that capability. And all the other things like checking things are equal, having a default value for your thing. Oh, there's loads of macros that just make your life so easy and give you these superpowers. Where the more interesting trade-off comes in is when you start writing macros and you might mess them up or they might not do the thing you expect them to do.
But that comes down to taking responsibility for your code. And that responsibility must surely extend to macros as well as the regular source code. Like, you have to know what you're writing, you have to understand it, and you have to take responsibility for it.
Yeah, but I think it's easier to write macros that are really weird and don't work the way most things in the language work than it is to write, like almost by definition, if you're writing a Rust function or something like that, it's going to work how functions work. But the cool thing about macros is you can make stuff work in a totally weird, different way, and therefore there's more damage that you can do.
But presumably that kind of damage can be caught by testing.
Yes, testing is the answer to everything, yes.
Right. Yeah, I thought we would end up here. Have you written macros that would have caused problems but were caught by tests then?
The other day I thought a macro was causing a problem and I wrote a test for it and it wasn't. Does that count?
I suppose so, yeah.
Back in the day when we were writing in Rust, there's a crate called clap, and there is a feature called the derive macros for it, where you can have a struct, tag this struct as your command line interface, and it will just auto generate a ton of code for you that has all the various, like, dash dash help and dash dash my argument with some value. There's all kinds of stuff you can do with it by just tagging it with these little macro attributes. And when going through and writing that, like, that was extremely, there is literally no way I could have gotten through that without testing. 100%. It would have done all kinds of wrong things. But I think that's also kind of the beauty of, for all of its faults, Rust's macro system, because it's so weird and outside of the norm, you're on a foreign planet. You know that you are doing something slightly strange here, and so you tend to take extra precaution or have extra testing set up. It's not as simple as just like writing a standard function and YOLOing it. So I like that it is slightly different. That's not to say I don't want, or that's not to say that I don't want any friction or that it can't be improved. It very well could be. But I also don't mind that it's like this kind of weird land, because you are doing weird things. You're writing code that writes code.
You have to be careful, I think. I have to be careful because it's really cool. You can call it metaprogramming, and then you understand why I think it's cool. It's such fun to be working at that higher level and doing something that's harder than usual, and, that's cool. But that can tempt you into writing a macro when actually there was a way of doing it that would have avoided using a macro, that would have been much easier for the people coming along later to understand.
Yeah, you really have to be careful with it, because when reviewing code, I very often see a macro use, and like my initial thought is like, this probably shouldn't be a macro. Let me dig into it and see why it really was. And there are many cases where the macro was fun to write, or it was interesting, not that it really needed to be there, and it might actually make like readability harder, or it might make maintainability harder. It might calcify code that really needs to be a little bit more flexible. So you have to be very critical of macros when you see them, and they can be alluring when you learn how to use them properly. You can do some cool stuff with them.
This all reminds me of Lisp. I have to talk about Lisp again, having talked about testing as my other hobby horse. The cool thing about Zig's comp time stuff is that it reminds me of Lisp. And that one of the nice things about using Lisp is that you can do a lot of so-called metaprogramming without using the macro system. So you can effectively write something that looks like it's like a new programming language that you've designed, but actually it's all just Lisp. There's a sense in which it produces code out of the code that you wrote. But then Lisp also has multiple different confusing macro systems depending on which Lisp you're talking about, and it all gets very exciting. But yeah, the thing that really attracted me about that Zig thing, and I haven't looked into it more, is that you can have some of that sense of, I'm just writing code, but it is still metaprogramming in the sense that it's code that's about code, and that gives you a lot of the power without stepping outside the language. One of the big disadvantages of true macros is that in some sense you're not writing code in your language anymore, you're doing something different.
An interesting criticism that I've heard of the Zig comp time feature is that it can end up getting used pervasively because it's just Zig code. It's very natural to want to write it everywhere. And also it replaces a lot of other things like generics are not necessarily used, or I don't even think they're part of the language because you have comp time. You can just write a little program that says what type something is supposed to be using. And I've heard the criticism. I have not really used Zig very much myself, so I can't say whether or not this is valid, but that with comp time everywhere, things do get a little bit harder to understand, or it's a little bit harder to read when there's just pervasive use of comp time everywhere.
The problem there is that if you have a pattern that everyone follows, like a language feature like generics, which everyone knows how that works, and then you replace it with a feature where you can just write any code, and if you want to follow a certain pattern, you can, but you don't have to. You can then end up in a situation where it looks like you're following the pattern, but actually you did something a bit different this time, or you don't quite understand the pattern, so you don't quite follow it correctly, or something like that.
Yeah, I guess that's the sort of push-pull or the tension between, do I have a very small language with a very powerful feature that lets you do all the other features with this one, therefore keeping the language small, or do I have a slightly larger language with more features, but each of those features is more constrained? And I don't think anyone has the right answer to that.
And it sounds like they can be useful, but they can be dangerous.
Sounds about right.
Well, on that point, then, we should probably get out of here. We'll be back in a couple of weeks. Until then, I've been Joe.
I've been Kevin.
And I've been Andy.
See you later.